Okay, so now we're going to look at the third part of the EX12 program that's in the Java 8 package in my live lessons GitHub repository. As before, we've got lists of characters from the play Hamlet. We have string of the character names. We have an array of lists of strings, all kinds of things that we can use various Java features to manipulate and massage in different ways. The previous two discussions were on the for each terminal operation and collect. And now we're going to turn our attention to the reduce terminal operation. And you'll see there's a couple of variants of that we're going to look at. So let's go take a look at the reduce test. You can see there's a bunch of them. There's 5 of them, and they all show off something a little different about ways in which reduce can be used. Now, not surprisingly, we're also going to use some of the other features we talked about earlier, like collect, but I'm not going to emphasize them in this part of the discussion. So here's the first run, collect, reduce one example. And what it's going to do is, the first thing it's going to do is it's going to generate the H characters map. If you recall, we'd looked at that previously, and generate H characters map is going to generate a map that contains the elements of Hamlet characters that start with uppercase H or lowercase h, and it canonically capitalizes them and sorts them. So that's what we're going to be working with here. We've got a map of these things where we're mapping the name of the character whose letter starts with H, first letter starts with H, to the length that they have. And then what we're going to do is we're going to take that map and we're going to go ahead and use the values factor method. And the values factor method on a map, as you may know, returns a collection of the values, which in this case would be a collection of longs. And then we're going to take that collection of longs and convert it into a stream of longs by using the stream factor method. And then this whole thing was just a setup to use reduce in some interesting way. So we're going to use the reduce operator. And this is the 2-parameter version of reduce. And what we're going to do here is we're going to first pass it in what's called the identity value, which for reductions that are additions or adding things together is 0. Because if you take a value and you add 0 to it, you get the value. So it's the identity value. And also, if we just happen to have nothing in our stream, then that would be the return value, would be the value 0, because there was nothing to sum. Because we do have something in our stream, we're going to go ahead and take each of those values and we're going to use the sum method reference from the long class in order to sum up the contents. So we reduce the contents that comes through here by summing together the values. And that'll end up with a count of the character name lengths, which we then go ahead and print as an output. So that's the first example. That's a very simple use of reduce, very common. You see this kind of stuff a lot when reduce is used. Let's take a look at some variants, however. So here's another example. And this example starts out much the same. We generate ourselves the map of characters that start with H that are capitalized in canonical way and sorted and so on. And then what we do, as we did before, we get our values collection from that map. We turn it into a stream, but instead of using the 2-parameter version of reduce, instead what we're going to do is we're first going to convert each of the stream of long reference types, which is what we have here. Notice we have a stream of long reference types. We're going to use the map to long intermediate operator to convert those long values to primitive long values. So lowercase l long values. So we've now got a long stream, and a long stream is just a stream of primitives that are longs. I always thought it was kind of ironic that the long in long stream is capitalized because it's really not capital long stream. It's lowercase long stream, but whatever. And then we go ahead and we apply the sum terminal operation, which is designed to work on long streams or double streams or int streams and so on. And that will trigger all the intermediate operations and then sum the results. So we end up again with a count of character name lengths, but we didn't use reduce here per se. We instead used map to long followed by sum. So just showing you another way of doing things. I don't know which one I like better. I probably, if left to my own devices, would go with the 2-parameter version of reduce, but you're welcome to think differently. So now let's go ahead and take a look at yet another variant of run, collect, reduce. And this is even more interesting. So what this is going to do, I should really probably call this one run, collect, collect, because it's not really reducing anything. It's reducing using collect. So once again, we start by generating our H characters map, and then we convert that map into a collection of longs. We now have a stream of longs using the stream factor method. And now what we're doing here, instead of using reduce, we're using collect, except now we're going to pass in the summing long collector. So summing long, as you may recall from our earlier discussion, is a collector that will essentially sum the values, in this case, that are reference type longs. It'll sum them, and it'll sum them together using the long value, essentially conversion operator on the long class to create a single long that's been summed together in lowercase l long. So this is just illustrating that you can also use collect to do reductions. Kind of up to you to decide what you like. I still probably would go with the two-parameter version of reduce left to my own devices. But again, it's just kind of interesting to see the different variants here. The fourth method we're going to look at is called run, collect, map, reduce. And just for kicks, we're going to do the split as stream technique that we did before. And so we're going to end up with a list of strings, which are all the characters in Hamlet that start with H, canonically capitalized and sorted, et cetera, et cetera. And then down here, this time we're going to take that list and turn it into a parallel stream, not a string. And after that, we're then going to apply the 3-parameter version of reduce. So the difference between the 2-parameter version and the 3-parameter version of reduce is that this is the map operation here. And this is what's run in a parallel stream in each of the different background threads that are part of the underlying common fork join pool framework. And this is going to do the actual first level computation. So what it does is it keeps a running sum. And if you want to see what this expands to, it's long sum string S. So we have a string of names and we're reducing them into a long. So what this is going to do is every step along the way, it's going to compute a new sum by taking the current sum and then adding to it the length of the given element that's a string in the stream. And each of those operations is going to take place probably in in a pool of worker threads from the common fork join pool. So that's the map phase. That's what all the processing gets done kind of in those different threads. And then after those things are done executing sequentially within a thread, but in the aggregate in parallel, we're then going to apply this combiner operation. So this is what's called the map operation, which is also known as the accumulator. So let's say AKA accumulator. So the accumulator is going to do that part. And then the reduce operation here, which is also known as the combiner. So we're going to accumulate and then combine or map and reduce. And what we'll end up with when all is said and done is a single value, which is the reduced result, which in this case is the count of the character name lengths. And this particular approach is really intended primarily for parallel streams, and especially if you've got stuff that has some different types that you're working with. We'll take a look at that more in the final example we're about to look at. Okay, so the final example here is a little different from the other ones. It's called run, collect, map, reduce EX for extended. And this also demonstrates the 3-parameter reduce operation and shows how it can do powerful things in its accumulator that you really couldn't do easily with the 2-parameter version. And this particular example is going to have a couple of maps. We have one called the baseline map and the other is called the actual map. And you can see that the baseline map has more entries in it than the actual. So we have a baseline with some values, and we have an actual, which has different values, the actual values as opposed to the baseline values. And it's also got one less key in it. So Wyoming is missing from the actual map. So now let's see how we can use this in conjunction with the 3-parameter version of reduce. So as before, we start off with a baseline. We get its entry set. So entry set is different from the values. Entry set is a set of entries, which are the key value bindings. So we have an entry set. We then convert that entry set into a stream of entries. And then we use reduce on this stream. And what we're going to do here is kind of funky. We're going to first pass in the identity value, which in this case is 0 because we're summing. And then the accumulator is going to go ahead and take what's passed in, the sum and the entry, and it's going to check to see whether or not the actual values, which is this hash map up here, contains the entry. Now, because as you can see, there's fewer actual values than there were baseline values, it's not always going to contain the entry, in which case we just ignore it. It's ignored for the purposes of this computation. So what we do here is we get the value of the entry, because we know we have that one. We check to see if there's an actual, and if there is an actual, we compute the difference between the actual and the baseline. And we store that in a variable called difference, and then we return the sum of the current running sum and the difference. So that's how we compute the so-called breakout factor in this case. And that all takes place, all that computation takes place essentially in the accumulation phase. And then the combiner, when we get to the combiner, we've got all these values, we just sum them up using the sum method. In this case, we use the double sum. And when we're all done, we've got the breakout factor. Now, we could run this in parallel if we wanted to, but I was trying to come up with an example here where you can see the value of having the 3-parameter version of reduce, even if you're not running the computations in parallel. So that was the final example. You've now seen a whole bunch of different ways of using terminal operations in Java, focusing on the for each family, focusing on the collect family, focusing on the reduce family. Of course, there are other types of terminal operations that are part of Java streams, basically things like all match, none match, any match, find first, and so on. We're not looking at those in this context, but be aware that they exist as well. So now that we walked through all the various examples of doing reduce, let's run the code and see what the output will be. And then we'll go back and see what the mapping is to the source code that we looked at before. So in this case, we're compiling it, and you can see here the various reduce outputs. So this is showing what we get with doing the first reduce. This first reduce we used was just the good old 2-parameter reduce, and it sums up everything, and we get 19 because Hamlet occurred twice, and Horatio was once, so that sums to 19. The second reduce that we did here, this is the one that used the map to, I think it was map to int and sum, and not surprisingly, we get the same results, just a slightly different way of doing the same thing. The run, collect, reduce 3 was the example that used the collect method with the summing long parameter, and that also produces the same results, just using collect instead of reduce. And then down here, we had the run, collect, map, reduce version, which is the one that used parallel streams, which was wildly overkill for that example, but it illustrates the point of why you would have the 3-parameter version of reduce, where you separate accumulator from combiner. And then the final version was the version that used that the 3-parameter version of reduce in the context of that breakout factor program that computed the difference between the baseline and the actual values for a subset of actual values relative to the baseline. So each of these examples just illustrates different ways of kind of slicing and dicing things to get, in many cases, the same result. But you can see that there's different ways to do it. And for simple examples like this, it probably doesn't matter. But if you have more complicated examples with much larger amounts of data to be processed, then making decisions to use parallel streams, for example, can be very useful.